video on chapter 11, prep practice vectors. So question 1, we're asked that if A is the point with coordinates 5, -4, to write down the position vector of A. So the first thing to say here is that a vector tells you how to get to a point. It has a magnitude and direction. So a vector is about giving you not only the length of something, but the direction you need to go in. So in this context, 5 -4 is a point in 2D space with coordinates 5, -4. So you can think of this as a noun. It's a thing, and we know its location. Now, a vector tells you how to get somewhere, and a position vector tells you how to get to somewhere from the origin. So the position vector of A is going to be, how do you get to A from the origin? And of course, if A is at 5 -4, we get there by moving 5 in the positive x direction using a unit vector I, and we go 4 in the negative y direction by using the unit vector j, which takes you in the positive y direction. So we need 5i -4j. So it's really easy. The coordinates 5 -4 becomes the position vector 5 -4 written in ij form, or using these column vectors, which I tend to prefer. So that's the first question. So the position vector of the coordinates 5 -4 are simply 5i -4j, or just 5 -4 as column vector. Question 2, the unit vector I, so I, j, k, these are unit vectors in directions r, x, y, and if we have 3 dimensions, z, their unit vectors respectively means their length 1. In this case, I is going to be due east, so here we are, due east, using this arrow here, and the unit vector j is going to be in the direction north, and then vector v is going to be length 10 in the direction given by the bearing 120. So you can see in this diagram, the vector v is this vector, imagine it has length 10, and it makes an angle with north of 120 degrees. And we're asked to find what this vector is in ij form, where I is a unit vector in the east direction and j is a unit vector in the north direction. So in the second year, we'll see that it's very easy to do this just by you can do it by just simple trigonometry. So if this length here is 10 and the angle here is 120, the associated angle made with the x-axis is going to be 30 degrees. And then using this triangle here, I'm outlining, then the horizontal length is going to be 10 cos 30, and the vertical length will be 10 sine 30. So the horizontal component of the vector is going to be 10 cos 30, which is 10 root 3 over 2, because cos of 30 is root 3 over 2, and that simplifies to 5 root 3. And the vertical component will be 10 sine 30, and sine of 30 is a half, which is 5. But remember that although this length is 5 vertically, the vertical component will be -5 because 5j will take us 5 upwards, and we want to go 5 downwards. So v is going to be the vector 5 root 3i minus 5j. And that will have length 10, and it will be in the direction which makes 120 degrees with north. Okay, question 3. Sometimes we're asked to work out a vector of length 1 in some direction. So in this case, the vector u points in the direction 3i plus 4j, but we want to still point in that direction, but we want to have the new vector to be of length 1. So what we do in these cases to get a unit vector is that we work out the length of the vector that we have. So in this case, 3i plus 4j has a length of 3 squared plus 4 squared, square rooted by Pythagoras. And so if we take the vector u and divide it by 5, we'll get a vector in the same direction, but length 1. So in general, what we do is get a unit vector, which is symbolized by the hat symbol. It's going to be the original vector divided by its own length. So 3i plus 4j divided by 5. And if we divide out each of the components, we get 3/5 I plus 4/5 j, or 0.6i plus 0.6j. Or you could write this as a column vector. But if a question gives you the vector in ij form, you should be polite and give your answers in ij form. And likewise, if they're given in column form. But you can work in whatever form you like. Moving on to question 4, really quite an important question. So we have points A and B with position vectors OA and OB. So OA tells us how to get to A, and OB tells us how to get to B. So in other words, A has coordinates 2, 3, and B has coordinates 5, 1. Let me just go through what we do in general, and then I'll explain why. So if we want the vector of B from A, we actually want the vector that takes us from A to B. Just have a think about that. So we want to get to B from A. So we start at A and we get to B. So the vector AB is the vector that takes us from A to B and is also called the vector of B from A. So how do we get a vector from one point to another? Well, in general, to get the vector from the first point to the second point, you always write down the position vector of the second point and subtract the position vector of the first point. So in this case, the position vector of B is 5, 1, second point, and the position vector of the first point A is 2, 3. So we just do 5, 1, subtract 2, 3. And we subtract 2 from 5 to give us 3, subtract 3 from 1 to give us minus 2. So the vector AB is going to be 3 minus 2. If I use the diagram in the question below, I'll try to explain why. So if OA is the vector that takes us from O to A, so imagine an arrow on this line going from O to A, and OB is the vector from O to B, imagine an arrow from O to B, we want to go from A to B. So going from A to B is the same as going from A to O, and then from O to B. In doing that, we're traveling along the vector OA, but backwards. So we want to travel from A to O first, so that's minus OA, and then plus OB. So the vector from A to B is minus OA plus OB. But typically, we write in the equivalent form OB minus OA, which is the same as minus OA plus OB. Well, I hope that helps, but if you're not sure about why, you should still remember the vector AB is always OB minus OA, the second minus the first. Right, let's have a look at question 5 now properly. So A and B have the coordinates 2, 3, and 5, 1. So in other words, they're the same as in question 4. The point X divides the line segment AB in the ratio 2 to 3. So we're looking at this diagram. This segment here, we can think of as having length 2 relative to this length, XB, which has length 3. And we want to find the position vector of OX. In other words, we want to find how to get to X from O. We want this vector indicating here. So how can we do that? Well, we can make use of the fact that the vector AX is 2/5 of the vector AB, because AX is in the direction of AB, is 2/5 of AB, because this one is 2, this one's 3, so AX is 2/5 of the whole, and XB is 3/5 of the whole. So in order to get from O to X, there's 2 ways we can think about it. The first one is from O to X is the same as going from O to A, and then A to X. So O to A, and then A to X is 2/5 of A to B. So we can take the vector of OA, which is 2, 3, and the vector of AB, which we found in question 4, was position vector of B minus position vector of A, which was 3 minus 2, and take 2/5 of that. So we want 2, 3 plus 2/5 of 3 minus 2. How do we do that? Well, we can do it component by component. So if you just look at the top component, 2 plus 2/5 of 3 is, well, 2/5 of 3 is 6/5, and 2 is 10/5. It's going to be 10/5 plus 6/5 is 16/5. And then if we do the same thing with the Y component, or the J component, we have 3 plus 2/5 of minus 2 is 15/5, plus minus 4/5 is 11/5. And so the vector OX is 16/5, 11/5, or you could factorize out the 1/5 and write it in this form. There is another way of doing it, which you're welcome to use, although most people will probably use the first, which is that we can get the position vector of OX by using a weighted average. So if this component here is 2 and this component here is 3, then what we do is we take 3/5 of OA and 2/5 of OB. And a way of remembering that is that X needs to be closer to A, so we need to take the bigger weighting of A or weighting of B. So we take this number here, which is 3 of OA, and we take this smaller number here, which is 2, so we take 2/5 of OB. So if we do 3/5 of vector OA and 2/5 of vector OB, we get 3/5 of 2, 3, and 2/5 of 5, 1. And if you work that out, you get exactly the same position vector for OX. And moving on to the last question, we have a regular hexagon, A, B, C, D, O, E, and in this case, it's labeled anti-clockwise. It's conventional to have a shape labeled by the vertices going either anti-clockwise or clockwise. The position vector of A, that's from O to A, is given by the vector lowercase a, indicated by this arrow here. And the position vector of the point B from the origin is given by the small case vector little b. And we want to work out these vectors in terms of the vectors A and B only. So the first one is the vector BA. So that's the vector that takes us from B to A. How do we do that? Well, if we use the method I told you in question 4, you simply say the vector BA is the position vector of the second point A minus the position vector of the first point B. So it's going to be OA minus OB. OA is just A and OB is just B. So it's going to be A minus B. I've written them in bold, but you would write them underlined. Remember, vectors need to be underlined or in bold, unless they have these arrows in the top. Okay, so that's the first one. I suppose I should go through also diagrammatically how to get it. So BA is going from here, B to here, A. So we can go from B to O to A, and that would be the equivalent to going from B to A. Going from B to O is going down OB negatively, so it's going to be minus B. And then going from O to A is going to be plus A. So another way of seeing the answer that B to A is A minus B is that it is minus B plus A. And the order in which you add vectors doesn't matter. So A minus B or minus B plus A. Okay, question OE. Question B, OE, asks to find the vector from O to E. And there's several ways of doing this. One way is indicated by this red vectors here. And that makes use of the fact that we can think of this regular hexagon as being made up of 6 equilateral triangles. If we take one of these and move them to here, we can see that the vector taking us from this point to here is the same as the vector BA, because it's made up of an equilateral triangle, and this vector here is parallel to this vector here. So if BA is A minus B, this one will be A minus B. And then this vector here we can see is parallel to OB, but because O to B is using 2 hexagons, this hexagon here and this hexagon here, then OB is going to be twice O to the center, and O to the center is going to be a half B, which is going to be the same as the vector we need here. So the vector we need from O to E is going to be A minus B plus a half B, and if we add them together, A minus 1B plus a half B is the same as A minus a half B. Another way of doing this is if you imagine the hexagon split up into 6 hexagons, and we want to go from O to E, that's the same as going from the center to A, and going from the center to A is the same as taking a half of OB to get to the center. And if we want to go back from the center to O, we take minus a half B, and then from O to A plus A. So from the center to A, we travel minus a half B back to the origin, and then plus A to get to A. And so either way, we get A minus a half B. And you might see it in yet another way. There's lots of ways of doing it, because the order in which you add vectors doesn't matter. And as long as 2 vectors are parallel to each other and the same length, you can use one in place of the other. Okay, I think that's it. I will stop the recording